So, hi friends, welcome to the session. Trust you are all doing well. So, in the today's session, we'll try to see the persistence and as well as the storage levels as we are getting some of the questions related to this persistence and as well as the caching in the storage levels. So, observe here, guys, a small analogy behind this thing. Assume that I'm having some sort of the RDD like this, RDD1, and again we are having some other dependent RDDs. Okay, likewise, there is a process. Okay, RDD5. Now, if you consider this particular RDD, it is highly influencing two things, friends, actually. One is RDD2 and another is the RDD3. Similarly, our RDD2 leading to RDD4, and there is an immediate effect on this particular RDD. At the same time, if I'm having some RDD6 here, okay, it is influencing both. So the point here is if I am completing the transformation on RDD1, hope you're all aware of what is a transformation and what do you mean by action. Okay, clearly we know that there are certain operations, no matter whether I'm working with the RDD or data frame or Spark SQL, we're having two kinds of the operations. Coming to the first, that is the transformation. Second is the action. Coming to the transformation. So just if I am talking about the transformation, it is not triggering. So it's a lazy evaluation. Okay, we many at times we have seen this kind of the thing. Second important thing is, guys, just we're having the concept of the action, which is nothing but immediately it is going to trigger, and this particular trigger is having the effect on the transformations also. So if you see this particular diagram, basically what happens is just I'm having the RDD1, and after completion of the RDD1, the action will be triggered and the outcome, okay, RDD1 outcome will be given to the RDD2 and it will be removed from the memory. But in case of RDD2, it need to be in memory until it is giving the outcome to these two RDDs. Okay, once RDD4 got the information, RDD6 also got the information from this RDD2, this will be removed from the memory. So the problem here is, friends, suppose if something happens to RDD4, okay, to this RDD4 before handovering the output or before getting the action result from RDD2, then again it has to start from the beginning. Okay, first it has to recompute RDD1. Next it should go to the RDD2. And then only after computing the RDD2, again RDD4 is able to perform the activity. But there is a solution with respect to the Spark orientation. Let me show you some implementation. So just if you are making use of the implementation, friend, just I have prepared some kind of the logic for us. So to clearly explain the things. Uh, yes, you see here, guys. So just we are making use of this convention. Okay, so I'm creating this particular RDD. You know that with the help of the with the help of the parallelize operation of the Spark context to notify you, just I have given this thing also. If I'm giving the Spark, which is the Spark session, Spark context, along with your uh, anyhow, we are using this Databricks community edition so that accordingly these version master application name will be decided. And this is the Spark context. Okay, basically this particular Spark context is very much near to the RDD, which is generally holding the low level activities. And another distinction between Spark session and Spark context. So the Spark context is independent, and of course it is heavily dependent on the RDD orientation. So all the RDD activities are associated with the Spark context. Whereas Spark session is not like that. If you consider this outcome, friends, it is making use of the Spark session. Internally, it is supporting the Spark context, Hive context, and SQL context also. So if you refer the Spark session, which is the advancement, which is holding all the possibilities of your Spark based functionality. Apart from the Spark, it is integrating Spark SQL in terms of SQL context. It is integrating the Hive context also. Now, just I am creating one RDD. So just we are creating RDD. There are multiple ways to create the RDD. One is with the help of the parallelize. Second thing is with the help of the range you can create, or else you can load the CSV files or whichever. Okay, based on that particular convention, according to the requirement, you can create the RDD. Now, the first point, guys, just I have given some kind of the example, like multiple RDDs are there. Once that particular RDD completes its activity and hand over the result to the next RDD, it is not required in the memory. So automatically Spark deletes that particular RDD from the memory. But the point here is if something happened to the current RDD. So current RDD is performing some activity, but to get the transformations or to get the output before handing over the output to the new RDD, if the existing RDD fails, for example, in that particular case, just we need to see some other alternative. Though one important point, guys, Spark by default provides the fault tolerance mechanism because it is a de facto standard, and where this particular Spark orientation generally observes the orientation of understanding the details and how it is going back, lineage and resilience. Already we have seen while discussing the RDD. Now in this session, we plainly focusing on how the persistence and caching mechanism helps us and which are all the storage levels related to these persistent caching. Reason is we are getting some of the questions from RDD creation. Of course, we have seen many times, and then persistent cache I'm going to introduce, especially the storage levels. Okay, with respect to that storage levels, we are having some chart where that particular chart gives us understanding of memory, disk, and as well as the heap memory, and thereafter deserialization and replication. Like that, we're having some sort of the mechanisms related to that RDD. Now, if you try to run this particular thing, just we are making use of creation of the RDD, and I have attached this cluster also. Now, initially, if you consider this point, guys, RDD1 is having certain aspects like, so just if I'm making use of RDD1, okay, there is a function, okay, there is a method, this is cached. Okay, if I want to get all the functionalities as this Databricks edition provides us the IntelliSense support. So is locally checkpointed or is empty, is checkpointed, is cached. Like that, we're having various functionalities. So at the moment you give the is cached kind of the thing, just we can get the outcome. It is false. That means whatever the method we have applied here is cached mechanism, and it is saying that this RDD1 is not cached in the memory. And to observe this point, friends, there is a concept called caching mechanism. If you are aware of that computer organization and computer architecture, there is certain aspect, friends, like where we are understanding, where we are identifying. Just let me show you this convention. Assume that we are running some program. Okay, so this particular program, active set of the program, this is, and this particular active set of the program is having some data items. Maybe generally in our Spark is basically in-memory computing. Okay, it is following the in-memory computing. So generally this active set, whatever the data we are having, this data will be picked up from the RAM. Maybe assume that D1, D2, D3, all these particular data items are required for the current program or current application. Now there is one more memory called cache memory. Okay, this particular cache memory containing most frequently accessed item. Assume that D1 is accessed 5 times, D2 is accessed 10 times, and D3 1 time. So obviously guys, the footprints of D2, because it has been accessed 10 times, and D1, it has been accessed 5 times. And maybe more than these D3, if any other thing is there, like 2 times or 3 times access, then that would be available here. Otherwise, D3 is also available here. It's not like 1, 2, 3 like that, most frequently accessed. So if you consider the cache memory, friends, cache memory is only containing the uh, most frequently accessed item, but RAM, which is having all the data items, maybe data item 1 to data item 100. Assume that these are all the data items we are going to work. But so far we have picked up only 3 data items, and those 3 data items we have accessed multiple times. So as a result, we are having that information in the cache memory. So now the advantage here is, friend, simple. If I am talking about the cache memory, your cache memory data we can access in the faster way. Faster way. Reasons are two reasons, friends. One is uh, limited items. Second is access of locality. Okay, compared with the RAM. Okay, compared with the RAM, your application is very nearest to the cache memory. That cache memory is available very nearest. So that what happens is just it is picking up whatever the application we are having. And if I want to get some kind of the data, immediately I can go back to the cache memory and I can pick up the information. Maybe RAM is for two things. Cache is better than RAM. First is limited items, because RAM is containing all the items. Definitely compared with the cache memory, RAM is having the huge data sets or huge items. But whereas in the second thing, RAM is not maintaining any repeated data or frequently accessed data. But cache memory is having the property of getting the repeated information. And this much we know from our engineering. Okay, like the computer organization and all those kind of things, we can easily observe that. Now the other point is, friends, how this particular cache is helpful in our in-memory computing. So the similar way, as I said earlier, so just assume that we are having RDD1, RDD2, and RDD3. If I am persisting this RDD2, okay, persist means preserving. I mean, after completion of the RDD2 action also, we are insisting, we are explicitly mentioning that, we are instructing Spark, I want to preserve this particular RDD2 in my memory. In my memory, in the sense, just I want to preserve that. Don't delete from the RAM. Okay, reason maybe this particular RDD is generating some results for multiple RDDs, or else I may feel this RDD is key for the sake of generating the results and all. So in that particular case, friends, actually outcome of this RDD1 is available with this RDD2. If any problem with the RDD3, but still RDD2 is in memory, which is available because we have preserved that particular thing. From this particular point only, I can regenerate the RDD3 rather than going back and starting from the RDD1, as RDD1 outcome is also held by this RDD2. And in fact, RDD2 also available in the persistent mode or in the cache mode. It is easy for us. It is handy for the RDD3. Okay, again, however, Spark is having the capability of resilient lineage, I mean, accessing of the data, so that from the source information, it is going to generate the RDD3. And now RDD2 is in force. RDD2 can assist or give the information to RDD3 in terms of accessing the data. So it need not go back and again reinvent this wheel of RDD1 starting from the beginning of this application. Okay, but how to achieve that? Okay, but how to achieve that? In the sense, just we are having some kind of the convention, as I said, just we are going back and verifying the implementation. Okay, just if you are considering this is cached, as I said earlier, if you are making use of this convention of understanding RDD orientation, just we are want to preserve the data. Like I am having some cached information. As just I said, how I am able to get back a particular RDD as a persistent mode. So just I want to mention this is cached. Actually, is cached is not replying anything. Now I want to persist that actually. So one important property provided by our Spark is I can able to persist the data, guys. Okay, persistence mainly specify that whatever the RDD I want to, whichever the RDD I want to maintain in the memory. Because while working with the memory kind of the thing, if I am not explicitly persisting the data, automatically it leads to elimination from the random access memory. Because until explicitly we are mentioning, until we are mentioning that particular persistence, there is no use of, or we cannot maintain the convention of RDD storage in the memory. So for that particular purpose, what we are doing is just I want to persist the RDD. Now you see, as a result of this particular persist, okay, it has not given, just it has given some reference as persist is heavily related to the memory orientation. Now what I want to do is I want to maintain, okay, whether this particular caching is done or not. At the moment we have seen this RDD1 dot is cached, it has written false. But now what we're doing, let us check once more. Okay, just if I am checking this particular convention, it has given true. That means now our RDD1 we have persisted, and let us see what exactly this persist is. So this persist along with the storage level, I'll come to that point, guys. A storage level is something like which is giving some sort of memory, disk, support of the heap memory, and then deserialization, replication. So it is having some 5 parameters. Okay, we'll talk about that. But as of now, just observe that this persist is a mechanism where I can instruct my Spark engine. So just you can keep this particular RDD in the memory. You can persist this RDD in the memory like that. So this RDD storage level to persist its value across operations after the first time it is computed. See the most important point, guys, because if I am not computing the RDD, if I am not applying some action on the RDD, it's not required, guys, because RDD merely maintaining in that particular memory is not going to give any advantage for us. Rather, what you can do is, if at all I want to maintain that RDD in the memory, make sure that that RDD should be computed at least once. So after computing only, that RDD is having the outcome of the previous RDDs, so that the current RDD can forward the outcome to the required RDDs. Okay, so that is the main important point. So what we are expecting here is this thing basically uh, after computing this particular RDD, this we are specifying, and we are not giving any parameters here. So remember that one time in the examination also they asked like if I am making use of the data frame, no matter whether that is a data frame or RDD, both are same. If I am making use of the data frame and I want to store my data in hard disk, okay, then without replication, hard disk without replication, then what is the storage level? What is the default storage level? So to answer that kind of the question, okay, we have not yet completed which are all the 5 parameters related to the storage level. And after completion of those 5 parameters, definitely we can able to handle the convention. Okay, so here we are guiding, we are directing our Spark. Okay, this RDD I want to persist. Can you help me? Now, if you observe your RDD1 dot is cached, yes, of course, your RDD is cached in the memory. Now observe here, guys. I'm still having some kind of the understanding like what is persist. what is cache, what is the get storage level. Now let us run this. What is the default storage level? So the default storage level, it is not mentioning anything because by default we are having these two things, these all things, disk, memory, memory and disk, memory serialization, like that we are having. So now the answer for this default kind of thing is the memory, friends. Actually, that is the reason. Okay, at this moment, just to observe that the second parameter is memory. That's what it is true. That's what it is true. So the parameter wise, if I need to talk, just observe here, guys. Just I'm adding one more this thing. And if you consider the parameter one, okay, parameter one, which is reference to the disk. Okay, which is reference to the disk. That means if your first parameter is true, then you are going to store your data into the disk. Whereas your parameter two reference to the memory and your parameter three reference to the heap and your parameter four reference to the deserialization and your parameter 5 reference to the replication. Now, if you are considering parameter 1 disk, but the default storage level, as I said, it is a memory because in memory computing, our Spark is basically supporting the in memory computing. So the second parameter here is true. And the third one, we rarely use this heap. And if interested, we are going to use the I'll come back to that, guys. What exactly serialization and deserialization? Let us confine to understanding of the persistent cache mechanism and all these storage levels and all the 5 parameters we are going to talk. Now, finally, the replication. Because guys, here, if you consider this default storage level, this is one because we don't in the Hadoop based kind of the file system, we are having that repetition. I can say at least 3 times a file can be repeated. Okay, that is what you call the replication factor. But whereas if I'm talking about the Spark based kind of the storage, there is no repetition actually. By default, it is only maintaining only one copy of the data. And if any problem is there with the resiliency, with the kind of lineage, okay, your Spark is going to handle the data. Okay, so there is no separate replication by default. And most importantly, fault tolerance mechanism is default or design principle of the Spark. Without persist, without caching also, Spark is able to maintain the backup copy of not backup actually. If any failure is there related to RDD, it can go back and recompute the same and it is pulling generation of the new RDD without any problem. So here the thing is, but why we need this persist or storage level, you may ask. Yes, at times, though Spark is having the capability of resiliency and as well as the lineage, think through, guys. Just if I am making use of 10 RDDs in parallel in the cluster movement, or maybe data engineering team is doing some processing, data science team is doing some processing, big data team is doing some processing, like that we are having some shared resources in the Cloud Era Manager or Hortonworks kind of the cluster, assume that. Now in that particular case, suppose if I want to perform some kind of the activity, if any problem is there for 2 or 3 RDDs, again Spark need to allocate some thread so as to go back and liaison with the source and populate the RDD to the corresponding machine's partition. Okay, though that convention is there, but the problem here is it takes much time, guys. Definitely, again, Spark need to perform some kind of the operations so as to get back the failed RTD. So what we are trying to do is, though Spark by default support the fault tolerant mechanism, but still our interest is so as to get the convention of, so as to maintain the convention of handling this persistence, where you can see that some of the RDDs you may feel that okay, I need these kind of the RDDs in the memory, so that that RDD is able to generate and maintain some kind of the convention of the data. So though if any failure is there, just with the latest persisted RDD, without going back and again start from the first statement, I can avoid the computing and I can able to get the appropriate information without any problem. Okay, that is something like which is very handy whenever I am dealing with multiple RDDs. So now the point is maybe I want to handle my data in both memory and as well as the disk, and I want to maintain the replication S2. That means in memory and as well as the disk at both the locations I want to maintain the replications. Now if you directly, okay, if I want to run this particular statement directly, friends, as your RDD already get persisted here. The important point here is already you have assigned the default persistent mechanism for the RDD. Here the point is though you are not mentioned any argument here, but by default we are having the memory orientation. Okay, this is the thing where you need to observe the memory relevant aspect is true here and your replication is one. All your disk and as well as this heap memory and as well as the deserialization, all these are false. Only the thing is by default your memory and as well as your replication factor just are in force related to the storage level. So whether you are giving the parameter or argument into this particular function or not, if you are mentioning the persisting of the RGD, your Spark is going to the in-memory kind of thing, memory based with single replication factor. Now the understanding here is, guys, maybe after persisting this RDD, I am not able to perform the overriding of the storage levels. Now for that particular purpose, what should I do is first I need to import the storage level. Okay, from the PySpark, just I need to import the storage level. And still if I am trying, because here storage level is not defined like that. Now, yes, I got this particular storage level. Again, I am trying to give the notion. Though I am trying to give what it is saying, guys, here cannot change storage level of an RDD after it was already assigned to a level. Because this particular thing, you know what it is saying, it is not allowing the user as your storage level is already filled up. Okay, it was already assigned to a level. So just I am pasting this thing, guys. So you can also work on this kind of the convention for the clarity. Just I'm pasting in the chat. Just this kind of the convention helps us. You are maybe you are using this memory and disk so as to convey, but basically that persist already happened, so it is not allowing us to leverage or to rewrite that particular thing. So for that particular aspect, what we are doing is again we are creating one more RDD. Just we are creating the RDD, and now see here the point is just we are trying to establish the storage level, memory and disk. Now you see run. Okay. Now at the moment, if you are making use of this thing, and if I want to see what is my storage level. Okay, get storage level. Now you observe, guys, here automatically you will be getting true, true, and as well as your replication is true. Because our as per earlier understanding, our first parameter is disk, second parameter is memory, third and fourth here also false, heap and deserialization. Fourth one is the replication. Now if you go back to this particular storage level, your memory, your disk is true, memory is true. Of course, these two are false. One is heap and another is the deserialization. And I explicitly mentioned that I want to maintain the replication. That is true. Okay, so here the understanding is simple, guys. Okay, if I want to mention the uses of RDD in terms of the disk based and as well as explicitly, but though our Spark is not allowing the convention, like directly I cannot able to override that. But from the perspective of loading the data, at the time of loading the data, if you are very clear that I want to maintain the convention of both memory and as well as the disk, you are free to do that. But now the point is, without persist, can we specify the required storage level or not? That means if RDD is not persisted by the developer so far, can we have the chance of persist to required? That means though you are not specify the persisted, I mean, suppose I have done like this, friends, RDD1 dot persist. Okay, can I specify another storage level? Definitely not, no? Because already this particular default, this is pointing to the default. Okay, this is pointing to the default. What it does is it is stick to the memory. Okay, memory orientation, not disk, not disk or heap or else deserialize. So can I specify another storage level? Answer is definitely no. Just be cautious, guys, because these kind of the questions we are getting. That's what I scoped this particular topic. Uh, the evidential answer is here. We have persisted and we try to update memory and disk here, but no luck. Okay, just it has outrated us, like cannot change the storage level of RDD after it was already assigned a level. We practically not assigned anything, guys. Just we have persisted actually. If you see, we have persisted. So that means that though we persist that particular thing, but still these kind of the conventions are not helpful. Okay, reason is the default persistence is this thing. Okay, false, second is true and all. Now, if you refer the further movement, just I am observing this storage level. One important point you need to observe, guys. Maybe that is the default persistence or persist with memory or disk, or persist with memory, disk and replication, and or else persist with memory, persist with disk and heap along with the deserialize with two serialize two replication. In all these kind of the cases, your RDD is cached, no matter whether that is a default persist or else explicitly you want to mention the persist with respect to the memory, disk or else your heap, all whatever the things. So the point is pretty simple, guys. Caching can be easily observe, okay, like any of the persisted RDD is cached by default. But one more important thing is, yes, that is cached, but what is the level of caching? What is the storage level? The storage level now you need to discuss, because we have seen that there are storage levels related to the memory, related to the disk, and then related to my heap memory, and thereafter the deserialization and replication. Our entire discussion is revolving around these kind of the aspect. So the option here is whatever the persistent mechanism you are using, your RDD is cached, but up to what extent it is cached, whether it is cached up to the level of the memory or it has been deputed to the disk also, that thing we have to see. Now the after implementing this particular thing, just if I want to get the storage level, now it is easy for us to understand. Like if I am making use of the above statement interpretation, so your first parameter, of course, disk. That is the reason why it is saying true. And your second parameter is also true because it is we intentionally mentioned disk and memory. And your third parameter of heap, okay, just it is false. That is what the reason. And your fourth parameter deserialize, it is also false. And your fifth parameter referencing the replication. Okay, replication. Now it is 2 because explicitly we have mentioned that replication as 2. Now, if you are making use of RDD, one more point, guys, here. I'm having multiple RDDs in the memory. like RDD1, RDD2 up to RDD100. If I want to cache all the RDDs as per my wish, okay, I am not bothered about the memory, or I am not bothered about whatever the specification I am having. Just simply I am populating the RDDs related to my wish. Then what is the implication? What is the implication? Simple thing, guys, because memory is very precious. And of course, if you consider the other way around, like all the RDDs, I'm persisting because my thought process is like this. Why should I leave, or why should I recompute all the things? Because if I am able to persist the things, then it will be better for my future reference. The problem here is, guys, along with the current RDDs, our in-memory computing of the Spark should accommodate the new RDDs also, as this is the distributed environment, as we are strongly dependent on the parallelism. In all the cases, just we are having the approach of, okay, we are having the approach of maintenance of the current RDDs along with the new RDDs. So it's not like you are only the user or the current RDDs are only the objects. Maybe multiple users are using the distributed environment, and there we are making use of the convention of handling the RDDs in the proper way. So for that purpose, we should be very cautious, because once you persist that RDD, it will preserve forever. Okay, until you maintain that unpersist. There is a mechanism called unpersist. So now you see here, just I am running this unpersist. Now if you see this is cached, okay, now we are getting false. Now maybe you are having some doubt. And what is my RDD2 storage level? Okay, because we unpersisted now. So that let us see what exactly our storage level. So just I'm getting the storage level, get storage level, and then you see this. I have unpersisted. Now you see, guys, after your unpersist, okay, let us try to substitute our parameters. Okay, after unpersist, our first parameter is disk. Of course, it is false. And our second parameter is memory. Friends, be cautious. After unpersisting, even in memory also our RDD is not there, guys. That is the understanding. And of course, the third thing is a heap. There is no chance. Still it is false. And the fourth option is deserialize. This is also false. And last thing is just replication. This is one because currently, though we are not persisting that is existing na, RDD is existing, because our RDD at the moment I am getting this RDD whatever the values I'm having, RDD2 dot some take or collect if I'm giving, okay, it is having some data, okay, that itself is saying it is maintaining at one time, though I'm not storing or persisting. We are talking about the persistence caching mechanism for the future reference. If any problem occurs, if something happened to that machine where we are running on the cluster, where our distributed mechanism is taking place, in those kind of the conventions only we are mentioning that point, guys, right? Okay. So what else we need to discuss? We need to discuss about the storage levels actually. So now let us jump start into the storage level, where if you are making use of that particular storage level, these storage levels are helping us to understand the convention of how do we make use of the different specifications of storage levels, and what exactly the understanding of the persistence and storage mechanism. So for that particular thing, I am having some compilation for us, guys, which is really helping in the examination perspective also. So just let me pull those points. Okay, so initially just we're having the RDD persist, where this particular persist help us, okay, to specify some kind of the points. Along with that, some other compilation also I'm having. So this particular compilation gives us a clear understanding of persistent mechanism, RDD, and what about the storage level. Now see here. Okay, so now we'll spend some time. Don't worry, friends. Simple thing only. Maybe in the while compiling, I compiled multiple lines. So don't worry about that. All essence is simple. So Spark RDD is of course lazily evaluated. It is true for even data frames also in all the transformations. And sometimes you may wish to use the same RDD multiple times. I want to use RDD1 multiple times as this is a source for other RDDs. Okay, that is one thing. Second thing is if we do this naively, Spark will recompute the RDD and all of its dependencies each time we call an action on the RDD. Every time, suppose if I am not preserving or if I am not storing my RDD, then suppose if any computing is required, again go back and recomputing. This can be especially expensive for iterative. Iterative in the sense repeatedly I want to perform some kind of the activities which look at the data many times. Just it is performing that going back and getting that particular source data. And another trivial example would be doing a count and then writing out the same RTD. Just I am counting that and performing the aspect. And to avoid computing RTD multiple times, we can ask Spark to persist the data. We have seen the concept of the persist. If I am able to say rdd.persist, this will be cached. This will be cached. Now, when we ask Spark to persist the RDD, the nodes that compute RDD store their partitions. Okay, whatever the RDD, whatever the data I'm having related to the partitions, partitioning is a mechanism where it stores the chunks of the data. Whenever there is a requirement, these chunks will be handed over to the corresponding transformation or action because transformations and actions are running on top of the this data only. Now, if a node that has data persisted on its fails, Spark will recompute the last partition of the data when needed. Suppose if any problem is there, for a particular partition with the, as I said, na, so like there is a concept called resilience and as well as the lineage with these particular properties. However, by default, Spark is having the design consideration, though that RDD fails. But why we are using the persistent mechanism is due to that particular thing only. It is for RDD, for Spark, it is very much easy to go back and pick up the RDD. And if persisted RDD fails also, no problem. Okay, if other RDD fails means we can get back the data from the persisted. If persisted RDD failed also, persisted RDD fail means what? If some portion of the partition data is unavailable in the machine, that means this entire RDD we cannot pick up or we cannot access. In that case also, again, it is making use of the resilience or lineage. In either of the case, okay, in either of the case, it is preferable to make use of the persist, provided if you feel that RDD is really helping us in terms of calculations. Heavy calculations are dependent on that. We can also replicate our data on multiple nodes if you want to be able to handle node failures without slowdown. Obviously, if most important RDD, I can able to perform the replication as I said, na, like how we have done disk, memory and disk and replication too. This means our disk is true, memory is true, and replication is true. Okay, replication is true. So that possibility is also there. Moving further, one of the most important capabilities is a concept of the persisting. When we persist an RDD, each node stores any partitions of it that it computes in memory and reuses them. Okay, just it is having the persistent storage with the memory and any dependent RDD can go back and get this particular information. That is the advantage. We can mark an RDD to be persisted using persist or cache. Either you can use the convention just to remember this persist. Maybe in certification, if they are asking cache also, you can put that as true. On it, The first time it is computed. This is a basic point, guys. First time of the computing, it will kept in memory on the nodes. Spark's cache is fault tolerant. Of course, we know if any partition of RDD is lost, it will automatically be recomputed using the transformations that originally created it. Because maybe the RDD is a combination of loading the data or map process or else flat map. And sometimes I may use the filter, whichever the means. Based on that kind of the convention, kind of the transformations we are using, obviously are going to get the convention of the corresponding transformations. And each persisted RDD can be stored using different storage levels. Like these levels are set by passing the storage level object. Now, one table I am bringing up, guys, which is the most important thing. A reason is with the help of that particular table, one can easily observe how many ways we can persist our RDD and how we are going to work with the RDD specification. Now have a look on this, guys. Okay, so just if you are considering our default storage level, uh, suppose if I'm making use of the RDD, just I am creating one RDD. And if I am persist on that without specifying any arguments, then your default RDD is this one, guys. Okay, first one is false. Your disk is false. Memory true. Heap memory false. Deserialization false. Replication 1. So this is what you call your default storage. Okay, without mentioning any argument to your persist method, I can say that is a default storage level. Whereas now we'll follow up this thing. Disk only. Disk only. Observe, guys, here. This is the disk. True. Second is memory. False, because I want to store my RDD in the disk only. Third is the heap. This is also false. This is the deserialize. This is also false. This is the replication 1. So if in the exam also, if they are asking disk only and which are all the corresponding parameters, then you need to write this is true. This is false, false, false 1. You can clearly see that. Just to remember these points, guys, because this is more generic way, 5-parameter storage level now. Right. Now disk only with the 2 replication. Consider this as a replication factor, and disk, of course, first parameter true, remaining all false, because we don't want to maintain our RDD in the memory or off heap, or else another thing is deserialization. Now memory and disk, guys, here. It is also most frequently used kind of the construct. Of course, replication is one only I want, and your disk is true. Memory is also true. Off heap and deserialization are false. So the first parameter, of course, disk. Second is the memory. Third is the heap. Fourth is the deserialization, and fifth is the replication. Like that you can observe. Now the another important thing is memory and disk with 2 replication. Memory and disk with 2 replication. Of course, replication is true. Your memory second parameter is true. Your disk first parameter is true. Now false and false. That is off heap, and as well as the last one is the deserialization. Now memory and disk with serialization, friends. See here. Memory and disk with the serialization. So memory true, disk also true. There is no mention of the replication. By default, it is 1. And we are not deserializing. False. And we are not attempting to store the data of heap. That is also false. I'll come to that, guys, because what exactly off heap is? Off heap is simple. Other than the JVM storage, if you want to maintain your data, then that is off heap. You may ask this one, what is the deserialization? See here. Deserialization is nothing but whatever the individual bits related to the corresponding RDD, they will be combined as one object. Okay, now what this object does is object is having the reference of all the individual bits, and this particular object can be utilized by either RDD or DF. The advantage of this deserialization is RDD or data frame need not go individually to each and every bit which is containing the data. Rather, they can contact this particular object as this particular object is having all the bits information. Okay, right. Now we are into this point actually memory and disk with serialization 2. Disk, memory, heap, deserialize, replication is 2. Now memory only, of course, we were talking about this thing is a default storage like false because no disk reference, true because of the memory, off heap and this thing is a deserialization, no reference of the deserialization and replication is also 1. Memory only 2. Observe here guys. I'm having the disk false, memory true, off heap false. Last one is the deserialization, but I want to maintain 2 copies as a replication because I feel that that RDD is most important to me. Yes, I can do that. Memory only with 2. Memory only serialization. Nothing great guys. Like this true remaining all false with but maybe you can see that this memory only and memory only serialization same kind of the approach. Yes, of course, some are like that. Okay, some aspects are like that. Now memory only with serialization too, only the difference is replication factor and this remains same comparatively compared with memory only serialization, memory only serialization too. Now if I am giving the off heap, observe here guys, most valuable point here. If I'm saying that I am going with the off heap memory, that means there is no JVM. Out of JVM, I want to store the data. Now here the point is your disk is true, your memory is true. What is the third one friends? Your off heap is also true, but I don't want to go by the deserialization, that is false. Though I am using off heap, it should be 1 only. Replication is 1 only. Now with this friends, whatever the question we may get in the corresponding examination of the Databricks, you can able to answer. But only the thing you need to perform is the very first point is the parameters, 5 parameters, parameter 1, your disk, parameter 2, memory, parameter 3, off heap, parameter 4, deserialize, and parameter 5, your replication. Your replication. Now observe here guys. If I want to maintain the disk, I should mention the true. This is also true. If I am mentioning this as true, that is the point guys. If I am mentioning as true, your disk, your memory will become true. Okay, deserialization always we are not preferring that, always false. Replication possible values are 1 or 2. Okay, maybe if I'm mentioning some disk and memory with two replication in those kind of the things. So based on all these 5 parameters, one can easily mention, okay, in what way we are making use of the convention for fetching and processing of the data. No matter whether I'm using the RDD or whether I'm using the data frame, in either of the case, just we can make use of the convention of this thing. Okay, along with this thing, I'll be sharing the workbook also, guys, just to notify. So just with the example, you can able to implement the logic. Okay, this thing
Sir,
and yeah, Rizwan, tell me,
yes. Sir, I have a doubt.
please.
In the morning, I was reading the document
Ah,
and I went through one of the question regarding this persistent cache.
ah,
So the question was, which
mm,
of the following operations can be
mm,
used to
mm,
cache a data frame only in Spark's memory, assuming the default arguments can be updated?
yes, yes.
Okay, so the
Ah,
option was data frame dot clear cache, data frame
ah,
dot storage level,
mm,
then storage level. D
mm,
is data frame dot persist, and E is data frame dot cache.
uh, data frame with clear cache. They are asking data
Yeah,
frame is cached or else clear cache. If it is cached, means which Persist they have used.
no, no, no.
Ah,
Wait, I'll.
yeah, yeah.
So the question is direct. Which
Hmm.
of the following operations?
Ah,
Wait, I'll
please, can you
I'll
share?
paste
Can you
the
able to share? Yeah, yeah. That is good
I'll paste
actually.
the question.
Just to paste that
So
because
the option
there
I
must be
pasted.
some twist actually. Okay, okay. Let me. No question also. You can give that. Which of the following operations can be used to cache a data frame only in Spark's memory? Yes. Assuming that your default arguments can be updated. This is
So the
not possible actually. Options you give, Rizwan. Let us see.
option is uh, I'll see. I can
Where do you get this
copy.
actually? Morning I have shared that document. Huh?
No, not like earlier. I got the
Ah,
document.
earlier thing. Oh, okay, okay. Maybe the
I'll not.
questionnaire or something. I would have given the answer also, no, Rizwan, in that case.
Yeah.
Yeah, answer also I would have given. Solution, maybe.
No, no, no. Yeah. Solution is given.
Ah,
Uh, my point is
just to paste
uh
that. So let us
yeah.
discuss. Yeah, yeah.
So the option is given.
Hmm,
So the correct option is D.
hmm,
So I'm thinking why
hmm,
it is not C, because if it is asking to cache a data frame only in memory,
hmm.
then by default we choose cache, right?
No, no, no. Actually, the thing is, if you observe the notebook, let me share notebook once again. So that is what there is one. Actually, these Databricks guys, just they are confusing more. Okay, so if I am not giving any argument to this, you see, if I am not giving any argument to this, it is definitely cached because it is true. But what is the default option here? Can you specify that? What is the default option here? Default option here is the
Memory.
memory only, memory only.
Okay.
But in our question, if you see, he is not even asking the storage level actually. He is not
Yes,
touch
yes,
based
yes.
on the storage level. What he is
Yeah.
touching is which of the following operations. That's what friend. See, cache. Let me see this way. Cache is what actually is a status, na? Cache is a status.
Yes.
What do you mean by persist? Persist is one operation or what? Operation only, na? This is the
Yes,
persist
yes.
operation. But
Yes.
whereas storage level is
Memory.
storage level, your expectation.
No, no.
Yes,
Yes, storage
memory,
level is
memory
it could be
or
disk
disk,
memory or yeah.
memory, whatever. Now in the question, just you are not bothering about disk or replication or whatever. You want to store in the memory. Okay, because you don't want to make use of anything. So this is the Sparks memory. And
Okay.
then one more important thing is just with the help of the persist mechanism. If you observe this thing, definitely after persist, no matter whichever the operation or whichever the argument you are sharing, whether that is the memory disk or memory disk with persist with replication too, you need to make use of this data frame dot persist. That's all. Here, if you are
Okay.
reframing, assume that default arguments can be updated. Can we update default argument Rizwan? To be frank, because even we have tried that. If you see if you
Yes,
see
yes.
this particular convention in our learning, that's what I have given this thing. It is cannot change storage level of RDD. It was already
Once it
assigned
is
a level.
assigned.
Then
Yeah.
there is no other gonna. There is no other gonna. If I am giving the argument set persist, if I am giving, did I mention anything? In the four levels, nothing is there. Rizwan, actually, we are safe because
Yeah.
if they would have given data frame dot persist of something, you may think in a different direction. But one important point is if you are using data frame dot persist, then it is not possible to reassign the storage level again. What should you do then? Again, you have to go back and create the new RDD. Then only you are able to assign the new thing. That's what we have seen here. Okay, hope this is clear for you.
So means like if we are giving data frame dot persist,
Mm.
then we can update the default argument.
No, we cannot update. That's what I'm
No,
saying.
no,
He's
but in the question it is saying
mm,
assuming the default arguments can be
mm.
updated.
We cannot update Rizwana. That's what I'm saying. Practically, we have seen na again. Practically now itself. See here, this thing. Actually, I have persisted. Now I am trying
Okay,
to. I'm trying to update the storage level. What it is saying actually, cannot change storage level of an RDD after it was already assigned a level. Okay,
okay,
and moreover, this Databricks also somewhat misleading. But only we need to give the weightage for what he's asking. Which of the following operation can be used to cache? Okay, yes, one thing is cache only in Spark's memory. These 2 points you keep in mind. Then you need to eliminate the remaining values. Okay, and you can land upon the persist. Okay, and of
okay,
course, assuming the default arguments can be updated, we cannot update that Rizwan, to be frank. Now, just now we have seen, because once
okay.
that data frame has been cached and persisted with the default memory, in memory kind of the thing, and even we need to update that particular kind of the thing, we cannot do that. If at all you want to do that, again go back, recreate the RDD, and on top of that only you need to create the your wish, whatever the storage level you want. Hope you got the point.
Yeah, yes, yes.
Okay, na? Right.
Yes.
How is your preparation?
It's
Uh,
going good, sir.
Going good, yeah. Daily that's what I'm not overwhelming actually. So some simple topics only I'm giving so that you can easy. When you are planning to take the exam, Acha?
Sir, actually, I'm planning to give Apache Spark Developer exam on 25th.
25th. All the best.
Thank you, sir.
Okay, no
Uh,
problem, Rizwan. You're having that Jeel. Definitely will be getting
yeah,
that.
but sometimes there is, due to there's confusions, lots of.
That is only. Yeah, you're right because it's not. I mean, if like we how we discuss in the session, with the discussion we can come to the conclusion. But in the
Mm,
examination, as a
yes, yes,
single
yes,
member. Okay, so yourself you need to see and discuss, but somewhat these are all not difficult. These are confusing actually. They are
yes,
all
yes, yes,
most confusing answers. That is only the thing. Maybe and one more thing, at least 2 to 3 options are very nearest.
yes,
Very
yes, yes,
near. That is
yes,
also
yes,
one
yes.
of the important point. Otherwise, we can easily crack that. Okay, then thank you. Thank you very much.
Okay, sir.
See you back.
Okay, sir. Thank
Yeah.
you. Okay,
Let
sir.
me post these things. Okay. Right.
Okay.
Uh, uh.
Bye, sir.